Okay.
You're live.
We're back with the web server frameworks working group. Slight hiccup from where we were at before, so our stream's gonna be a little disjointed, but picking up where we left off. All right, so yeah, the summary of kind of where we're at. A quick version is current the current status is it's a mess. We have different implementations that are hard to maintain for everybody and hard to use for everybody. So what we want to get towards, what I'd like to move towards, is an approach where we can start unifying the HP implementations within Node, and basically working to retrofit the HP1 and HP2 models to where they are closer and more similar to what we're doing with HP3 and Quick. So that we can have a single model moving forward that makes it easier for the web server frameworks to consume, and then taking parts of the higher level HTTP functionality and moving that out to the responsibility of this working group and the frameworks. So whereas right now HP1 and 2, if you look at it, really has that kind of high level HP specific API, right? You can set the headers, and you have it's very HP specific. What I'd like to move to is a more generic kind of protocol level core API in Node, and leave it to frameworks and modules to provide the higher level API bits. So I mean, one way to consider it would be the difference between HP2 core and HP2 compat APIs, where core, Node would just focus on core, and then the compat and those higher level pieces would be the responsibility of this working group and the frameworks. If that makes sense. That's the short version, the short summary, and then we can open it up from there for discussion.
So, I mean, I think we slightly discussed this in the last meeting. How similar can the core API be in terms of 1, 2, and 3?
So with 2 and 3, it's already pretty similar. We have this model of session, a session and stream, where the session is the abstraction of the stateful conversation, right? The stateful connection between the two peers, and then a stream is the actual data flow going back and forth. With 2 and 3, because we have multiplexing, then the model is basically just you can have multiple streams at one time over a session. With HP1, the abstraction would be just you have a single stream at a time over a session. So we can still model, we can still have it be the same session stream model. It's just the difference would just be the number of concurrent streams you can have open. So I think I definitely think it works. The one place where it's different from where it's at right now, if you look at the current HP1 implementation, in the JavaScript side, we completely mix what is API implementation, what is protocol implementation, what is the state management. Everything is mixed together, which is part of what makes it so hard to maintain. This would require separating out those layers so that we have a distinct API implementation versus protocol implementation. So it's quite a bit more work on the HP1 side and to get it there, but it is possible.
Well, would we rewrite from scratch or try to?
I think rewriting the HP1 stack from scratch is the easiest way.
Yeah.
Right. So it would be similar to the situation we have with the URL parser, right? We'd end up with another HP1 stack in core, but one would be legacy, one would be new, and the idea would be to move away from the legacy one over time.
So how important do you see consolidating a compatibility API between HTTP1 and HTTP2 and 3? Because I'm actually not sold that that's super important, other than the maintainability from the core side. But I think from the framework side, if we're moving toward what it seems to me like we'd be moving toward is a 3-layer or a 3-tier setup, right? Where we have the actual core APIs, this working group, our team's layer, and then the actual frameworks that the user interact with. And so it seems to me like if we're going to add another layer, we can actually pave over some of those differences in the mid-tier, as opposed to you having to do a lot of extra work in the core layer to make them equivalent, right? Like to me, that seems like the right layering. Does that go with what you're thinking?
You absolutely could do that. And when I was taking a look at it, it's just a matter of who wants to do the most work. If we try to paper over the differences in that middle tier, that middle abstraction layer, then this working group is taking on a large amount of work to reconcile those APIs, and the differences between those, right? Whereas if we do it at the bottom layer, core is taking on the burden of doing that, and then that middle tier doesn't have to do as much. It's still the same activity that has to happen, right? It's just where do you want to do it, and whose responsibility is it?
Yeah, so that's part of why I'm not super. So if you do a lot of extra work in the core implementation to pave that over, that means that if there was somebody who wanted to deviate from that compatibility in their own mid-tier, say they wanted to just use the low-level stuff, you'd be doing a lot of work there that they wouldn't be leveraging. I think if we have, sorry, Teo joined. Oh, I'm not host anymore, so I can't.
Yeah, Michael, if you can bring Matteo in.
So it seems to me like if we've got to do that work, having a clear idea of it being in the mid-tier as the compatibility between the low-level protocol implementations, which are specific maybe to their HTTP 1, 2, 3 level, and then having the mid-tier be that layer, actually to me makes the most sense, because it gives folks the option to rewrite their own mid-tier if they wanted to, especially since we're going with this, it's not quote unquote in core, it's not the core implementation.
If that was the only consideration here, then I would agree with you. But the maintainability within core of these separate APIs is also a challenge, right? And we have had unfortunately a really high number of security issues in the HP1 stack because of how it was implemented. Way too many. There
More
are
to come.
Maintaining the behavior of HP2 compat and making it work like HP1 has been an ongoing headache for a while. I know Robert has spent some time trying to get those reconciled, and it is a pain. And the fact that we're going to have HP3 come out with a different set of a different API approach, it's just going to end. It makes it just difficult for us even in core to maintain it. Yeah, and I don't see that problem getting any easier if we keep going down the separate stack path, right? So yes, we can do it in this middle tier, but if we do it in the middle tier, it doesn't actually solve any problems for us in core. So I'm kind of looking at it from the point of view of let's try to solve both sets of problems.
But I guess you're talking about that if it's outside core, it doesn't replace the other ones, and therefore it's the problem, right?
Yeah.
But I wonder, like we've on a few different conversations, we've floated the idea of like a library that would go along with, that's not necessarily in core like in the binary, but would come along with it. I don't know if that would be an option to replace those existing APIs, but not have it as closely tied. That's all.
Yeah, I think that's kind of that middle tier that we're talking about. Yeah, is so really low level within core. What we ship is we basically step back from the existing HP1 API and HP2 compat API, and we rework those into a single consistent, really low level API. And that's what we ship in core. And then you have this companion module, this companion library that provides those higher level APIs that work across those. And then the frameworks can build on those.
But
that's
are we
really the model
just
we're thinking.
talking about shipping? Like, I guess I was trying to explore is like, even if we had that library, we might ship it as along with the along with the node distribution, even if it's not part of core. And if you did that, it might still offer a way to replace the functionality we currently have in core.
Yeah, I agree.
Included vendoring. And yeah, the original discussion, which I think is still on the table here, is vendoring it in. So it would be shipped, and documented as to an end user. It might look like it's in core, right, as a vendor thing, but the actual maintenance of it and management would all be in a separate project.
Because I think in that case, Wes, that would address the concern you had, right? Where if somebody wanted to replace that, they could, even though they get the other version, they'd still have the separate piece that they could then more easily replace or change or whatever, right?
Yeah, true. I was mostly considering whether or not, and this was me not knowing and sort of asking if it was the correct decision to put all that complexity in the core layer or in our mid-tier, whether or not, we know that most users are going to just use the mid-tier we're talking about, but it was just where does the complexity live is what I wanted to poke at. But it sounds like James has a really clear answer for that. So that makes sense to me.
Yeah, as long as it doesn't need native code, then it could probably be in either place, right?
For that high level API, yeah, that entire higher level API should be completely JavaScript focused, and not be the native stuff. The underlying protocol implementation, right? What I imagine going on the HP1 is, if we separate API implementation from protocol implementation, the protocol implementation would be at the native layer, in order to get the most consistency with what we have with HP2 and HP3. In Quick right now. That's where it would exist. But JavaScript side would be, here is the, that API, the JavaScript part of it comes from this vendor did module, the public facing API.
Right.
And now I don't want to minimize the amount of work that's going to be involved in this. This is not trivial. We're talking about rewriting the HP1 stack in Node, and making significant changes to the HP2 stack to bring it in line with what's been happening with Quick, which I believe, basically the way that I'm going through and doing the Quick implementation is based on all the lessons learned from doing HP2, in terms of a better way of doing it. It's not a huge departure, but it's just the typical, small amount of engineering, small amount of code that just needs to be written, and it could take a while to do. But the most significant change, it will be on the HP1 side, which will require a fairly major overhaul.
James. There is one problem. There's a couple of problems in all of this that I don't want to be I don't want to bring bad news. Like, a significant one of the problems that we will never be able to actually refactor HTTP1 was because almost a lot of first generation frameworks for Node.js and HTTP clients for Node.js tapped into internals to do what they needed.
Yep.
So I don't know how how can you keep backward compatibility with those?
I think you might have joined after I mentioned this, Matteo. It's going to be very much like the URL parser. It's going to be a brand new code path, and there'll be a legacy stack, and then there'll be the new stack, and we'll maintain backwards compatibility by maintaining the legacy stack for a while. We won't be changing it. Yeah. We'll add something new.
James, do you think it's possible for us to align into the API that's going to be exposed from core so that we can have those efforts happen in parallel instead of?
Yes. Yeah, okay. That's absolutely something. And to be honest, I would absolutely love somebody to help take this on, because if you rely on me, it's going to take a little while to do. I'm happy to sit down and talk with anyone that wants to start taking this on, to walk them through what the high level model is for the session and stream basically, think of it as socket session stream model. Where socket is that's the UDP or TCP layer. That's the actual sending the data. The session is managing the state for the conversation between the peers, right? And then the stream is the actual data flow, right? What I imagine for HP1 is it's the same model, but there's a limit on the concurrency for the number of streams per session at any one time. Right. So if someone wants to start working through that, then absolutely happy to work with them to do.
And to also point out, I think there's 2 layers that we want to have an API design for before we get too far. I think we need the front layer, which would be the middle tiers API, so that we can make sure that it maps cleanly, performance-wise, and all that to the lower tier API, right? Because I think that's going to be making sure we have a clear understanding of those in parallel is going to be important.
Yes.
Also, something we mentioned as a side note was the differences or similarity between a client and server-side API.
Yes. So we'll say, for HP2 and Quick, if you look at the core API, there is very little difference between client and server side. With Quick and HP3, it's really just going to come down to you have a Quick socket that can either listen or connect. It can do both, and a single Quick socket can actually be both a client and a server. You can use it in both roles. Those will create a session. Right now, there is slight variations in behavior between a client session and a Quick session, or in a server session, in either of those cases. But once the communication is established, once the communication channel is established, they essentially act exactly the same way, right? They either create streams or receive streams and facilitate the state management between the 2 peers. The HP2 stack, if you look underneath the covers, it's roughly the exact same thing. Once the communication channel is established, those sessions on either side are following essentially the same state model. So because of that, if you look beyond, like the fetch level or the library level, framework level of an HP client, under the covers, it does not operate any differently than a server in terms of the data flow and what's being passed back and forth. So that low-level API that we're talking about in core will handle both of those, right? Both client and server. And what we'll look at is the middle tier to provide the actual end user API difference between those, right? You might have a middle tier that provides a fetch API that that's able to do HP1, 2, or 3, right? And then a completely separate server API. But those are going to be mapped. It's the same model underneath. Okay. There are differences. There are definite differences between it, but for the most part, I'd have to say that those end up being more surfaced just in the way that they during the time that the handshake is established, and in the way that some of the kind of superficial edge cases are handled. Again, I don't want to minimize this. It's a large chunk of work. It's going to require a pretty significant effort.
It would be interesting if we could.
Just to point out, aware of time, James said he had to leave at the half-hour mark. If there's anything very pressing for him, we should tackle that first, and then we can move on to the rest of the.
Yeah, I have a couple-minute leeway. So.
Yeah, I think it would be interesting if we somehow could split this up into chunks of work that we can actually make iterative progress on.
Yeah, I absolutely agree. Like I said, if anyone wants to start taking a look at the HP1 stack while I'm working on the Quick stuff, then that would be fantastic. That's one piece. That's one chunk, is just how do we start refactoring the HP1. The second piece is what changes do we need to make to HP2 to reconcile it more with what we've done in Quick. And then the third piece is how do we come up with a common base for those, right? So, so it's not still 3 separate code implementations, right? So once I get a little bit further along in the quick implementation, I'm actually planning on abstracting out some of those base level interfaces. You already see that in the C++ to some extent around things like HTTP headers. They're, the HTTP2 and HTTP3 implementations are using common base classes for headers and some of those things. We'll want to do the same thing with the base level socket, stream, and session interfaces at the native layer, right? And we'll start unifying some of those code paths. But that's kind of the third piece of work is to do that. So HP1 can be a separate work that somebody can start now. HP2 reconciling that with what we've done with Quick, and then reconciling the base layer. The fourth piece of work is the one I'm already doing with this, the Quick and HP3 implementation. Those can all be done in parallel.
And
Okay, go ahead, Robert.
Would it be possible to start implementing or start looking into the high-level API based on the existing low-level HTTP2, HTTP1 implementations? Because that, I think, would be easier to approach for more people.
Yeah, so we'll call that the fifth piece of work then. Start looking at that layer. Can definitely be done.
I think we should open a separate issue for that, and I think even that will be able to break down into a bunch of things we can start looking at in smaller chunks or in parallel.
Because I envision we could meet James somewhere in the middle there.
Yep. Okay. Did you have something you were gonna say before Robert started talking?
No, I just want to ask, it seems like you have an idea on your head, at least a high level, how things should work. It would be great if we can go schedule a session with you and some of us can go through what are you thinking for the high level API, and so that we can further help with this effort.
Okay. Yeah, up to this point, my head has primarily been in the low level stuff, kind of the stuff that what Core would provide, and then, and then a higher level API in terms of what the user facing with, I haven't really got into that mentally myself yet, but we can definitely schedule some time to kind of go through what that lower level model is, and we can talk about it both in the specific instance of what we're doing in Quick, so you can put, kind of make it more concrete, and then we can go through it in the abstract. So we start talking about how to adapt it to the other HP1 and HP2. So yeah, happy to do that. I can set, I'm looking at the calendar right now. I can set some time up probably late next week if we want to go through it.
Okay, that would be great.
Okay. So. All right, I do have to drop and run to another call. So I'm sorry to dump all that and then run, but feel free drop any other comments into 55 if there's any other questions that we can kind of work through from there. But then, like I said, next week we can go through more detail.
Yeah,
okay.
Thanks for that.
All right.
We'll talk to you later.
Bye. Bye.
So I was thinking maybe now that we've gone through a lot of the details on the lower level stuff, I think maybe we should spend a little bit of time on what we think the higher level API should look like and start organizing, some of the plan there. With James clearly leading the low level core part, I think we need to establish what we think the high level stuff should look like. And then we should also establish who's going to be involved in that and what we want the process to look like. Yeah, go ahead, Pete.
Wes, it seems like there is a message. Oh, the message from you. Someone should promote. If someone could promote Ethan.
Done.
Okay,
thanks.
So for my, opinion here on the higher level API, I think, one thing we should learn a lesson from is that first generation, like Matteo said, of frameworks and where things went wrong and where, we can really look back and say, yeah, the coupling that happened here is broken. Let's avoid it. Matteo, maybe do you have any ideas on specifics. You know, I think we can look at things like web standards. You know, that we talked already about the header APIs. I'm sure there's a lot of others.
There are a lot of things, like it's really hard. I will probably go a little bit brainstorming here. I don't have a list, an ordered list of things. Okay, I'm just going through. I think the biggest problem is Node core streams. This is the #1 problem. Okay, and saying that a request is a Node core stream with some property attached, I'm not fond of. Okay, I will just go to be very clear, especially the way we have it in Node.js. On top of that, we have the state management of a request that is problematic, and there is the tie between the request and the response, and the fact that they are two separate Node core streams, which causes so many problems because they are intertwined and they make no sense for them to be intertwined. And the fact that if you destroy a request, you also go to destroy the underlying sockets, which it's all sort of problems. Okay, so for me that is, and Robert can talk about all things, like, you know, there's endless problems that come from this. Some of the problem, it also comes on the level of they're related on the readable side, but also on the writable side, because the fact that we don't have a clear like state machine, you now have Express that to provide, for example, compression, it needs to hack into the prototype and change things. And the same does Restify. Or the approach that we do with Fastify is completely wrap it and say, okay, we're not touching those objects. We're just, you know, moving things back and forth to it. And so completely shielding the user from those, because essentially they are complicated and hard to use. And
that's one common thread, not just with the way we interact with streams, but I think moving to a wrapper object that abstracts this stuff away, I think in general is just a great idea for a lot of reasons.
Yeah,
so I think if we just say foundation, we're not going to muck with the prototype, we're not going to do the stuff that, you know, Express has been doing, is just, I think, table stakes here for this API design.
Yeah, essentially it needs to be an API that enables like frameworks to do what they need to do without at a good performance, providing good API, a usable API to the users, but on the other side, not requiring like mocking and monkey patching and stuff. There's a few culprits on this one. And one other problem is the unfinished. And this is actually a really problematic piece of code. The way that there is the unfinished module, and it's of the Express stack, which plugs into a lot of pieces in Node core, which, you know, it's another example.
Has broken more times than almost any other Express package.
Oh, I know that. I've been involved in a lot of those discussions. So it's really like even maintaining even providing that level of information to frameworks is without having them to do shenanigans to make things work. It's really, really needed. So I don't know how we can do it, but so for me, that is those for me are the major goals, if you want to call them goals.
So the unfinished module is almost directly related to your points on the fact that we're exposing the streams API, right? Like that's the reason why we have that. So if we abstract away the stream underneath our top level API, I think that module goes away entirely. It no longer is a framework concern. It's that our response API has a onComplete callback, where the complexity of whether it's well, at that point it'd still be a stream under the hood. It would be one of these new quick streams or however, you know, the underlying API is. But the point is that that complexity would never be surfaced to the frameworks at all, right? The framework would just say, hey, I want to know when the response handling is complete, and that's the end of the complexity for them.
Yeah, I think that observability hooks all over the life cycle, it's going to be a big thing for this.
I guess that we are in a very good position that we can actually compile a wish list, given all the history there is from all the code we wrote in the past 10 years at this point, of something we would like to have, and then start also designing the API over this. But also, I think that before to actually finalize this high-level API in this new module, we should give some time to frameworks to try it, maybe in a separate branch, in a fork, and go through a heavy second cycle of feedbacks.
Matteo,
I agree with that, but oh, go ahead.
What about the HTTP2 API? Like, it's not haven't been used a lot, but like, well, what's the opinion there?
Let me just interject my point on Tomas's thing. For Express, this will be a complete rewrite. I guarantee it. There's just no way. Express has too much legacy here to be able to effectively adopt this new stuff. Even for HTTP2, you know, which is why the work didn't get done. There's a ton of complete rewrite that needs to happen. So I am happy to work on that part. But actually getting users on it is not necessarily going to be the same as it would for like a beta of Express, because it's just going to break so much, is my guess. That's not a bad thing. I think that's a good thing. And I think it, you know, but I think something like a branch in Fastify may be a better, you know, I don't know how the, you know, y'all on Fastify feel about that, but might be more effective as a first step. And then we can look at what the Express rewrite, you know, Express like API on top of the new, you know, mid-tier layer is going to look like. Because I think, you know, to Robert's point, what about HTTP2? It's like we haven't even, you know, what about it? How are we going to get people using this if they're not already using it in Express? Because they're not.
My take is that, you know, Fastify is actually like, I am waiting for a quick version of something to test things. Like the compatibility layer, right, that we have right now, it's we are using HTTP2 with the compatibility layer because it simplifies a lot of our, you know, internal development. But the vast majority, like having some sort of path, like having a branch or even having some pathways where we are using the low-level bits. I don't know what Thomas thinks, but it's going to be some work, but not a complete rewrite, mainly because we have our own objects anyway. Because essentially it came to a conclusion that because Node Core did not provide any of those hooks in the life cycle, you needed to, and if you wanted to provide that life cycle flow, and I don't know if you're familiar with our life cycle, but it's our hook system, which I think it's really powerful and interesting to check. It's I think from my side is a really yeah, thank you, Thomas. It's a really good model of where a user might want to put things in. Not that we need to opt out the same, but at least that's where what we veer to, what we end up implementing because of the different requests that we had. It's so it's actually really cool. So I am so because of that, I think it's totally feasible to have some stuff in there. Now it won't be happy that the TypeScript people will get crazy, but it's I'm sorry about this, sorry for the reference, but it's essentially like typing HTTP and HTTP2 is a mess. It does not work. It's Ethan can tell a few things about this, how much effort it took him to make HTTP and HTTP2 types to work with, you know, with the whole Fastify system APIs. so that you can actually use the library which without saying, oh, this is an HTTP server at every single time you interact with the framework. Okay, which was pretty great. But we are going to add one more crazy, impossible ways of typing this. But I think it's doable. So it's I am actually really keen on hacking something together, to be honest. So
I would like to hear more about that, because I think that we should make that a primary concern. Maybe not primary, but at least secondary. Is like all the API designs should consider what supporting type systems might look like. I don't think we should over-index on it, but I think if we were to redesign something that is just as hard to type, I think we are doing a disservice to the entire TypeScript community. So.
Yeah. So like a general, short take on like what it took for Fastify was, we have a lot of moving pieces. Of course, like every route, every handler, every hook, and then potentially plugins and middlewares and everything, they need to know what kind of instance they're looking at. And so that sort of needs to get passed through a lot of places. And that's hard to do with types because the really only way you can pass like an instance of something through types is by using generics, and generics can get messy quickly. So the overall experience that we sort of arrived to was like starting from that first function where you first configure your Fastify server. It uses a discriminant union, which sort of logically decides what kind of instance the underlying HTTP server is, and then it uses that initial logic, that the decision, and then passes that type through to every single generic on the rest of the object, the rest of the instance, and then everything from that point onward in your app infers back to that initial configuration. So it's quite like smart per se, but yeah, it is complicated to maintain. And if you add a third thing, or I guess if you add like a fourth, because we technically have HTTP S and 2, if you add a fourth thing, we just have to keep tacking onto that overload and figuring out what the discriminant union would need to be to associate another kind of server type. What we used to do though is we used to make the user specify it themselves. It was like bring your own HTTP types, where it was like, you tell us what your server is through the initial generic, and then we'll pass that through to everything else. But we sort of were able to get rid of that. We still support that if you do want to bring your own HTTP server, but now we sort of say, you're using Fastify, you're using Node.js, you're most likely using a base HTTP instance. Let's make that decision for you by defaulting to HTTP and then enabling you and then figuring out through the options object which other ones you're trying to use.
So it seems like it's just the start of having one base here is going to already help solve that problem, right? Like we're not going to have an HTTPS, HTTP, HTTP2, HTTP3.
Yeah, also, if I may add a bit, another very, very annoying bit of supporting TypeScript is that other than being complicated, as you have just listened, is testing it. There is currently, we are using something that works for testing the handwritten types, but still there is no official way for doing it. It feels kind of hacky. And even if you can take a look at the Fastify types test, there are a lot of them. We got a few breaking changes or a few issues because we missed something. So definitely, if someone can pull some strings at Microsoft and tell to them, please help us making the types testable, will be great. Otherwise, it is currently above buff and will continue to be.
Yeah, types are tough. I'm working actually with the TypeScript team now to work on their documentation for types. They are like, with the whole new ESM stuff, we've like rewritten a lot of the like what is a module, what is considered a script, what is considered a global, Fastify's types are in there actually in the documentation now as one of the examples. So we're working on that, but yeah, it is hard to test types because the real happy path there is like just use TypeScript and like generate the types. But obviously that's not the solution. You know, we got to try and meet in the middle. So there's potential, but it's definitely a difficult challenge.
Yeah, I don't think
Yeah,
we should
that's
be-
going to be hard. Sorry, that's just going to be hard to get everyone there to be on board.
Yeah, I think TypeScript will get us off focus.
I would
I
definitely
agree that should not be
Well,
the main focus right now, but
There
it's
is
definitely
one,
something we
sorry,
should
there is
take the
one
next step.
thing that we need to take care of, which is all the tree implementation needs to have the same API and the same root at the core, at the base level. Sorry to be, this is for me, that's kind of the source of all the problems. And it should not be so deeply tied with internals. So to be like HTTP1 specific, like the problem with incoming message is that it's so HTTP1 specific that you can't really use it as a baseline. Okay, it's you know, it's just a and not to talk about outgoing message, which is even so much funnier. that is the true surprise, right? Incoming message you might be deal with, but outgoing message, that's the real surprise for all of you. Okay, that's the Easter egg. That's one of the nice Easter egg of Node.js. Well, we tell you it's a writable stream, but it's actually not. It only quacks like one.
It's writable like.
It's writable like, yay, stream one. It's like, that's the most piece of legacy thing that we have in Node.
So for that, I think, you know, there's some abstractions we can come up with. I would really love for us to take a look at if there's overlap with other web standards that we could, you know, base around, and obviously not exactly copy, but you know, as a starting point, I think that is a much better starting point than looking at what we have today in Node Core in some regards.
So one time, a long time ago, myself and Jeremiah and a lot of other folks were designing this thing. I don't necessarily know if it makes sense. It's but it's fast, okay, and it removes a lot of heavy weight. I don't know if it makes any sense, but this has been put a lot of thoughts and is actually really fast. I don't know if it makes sense though. So I'm just putting it down there. And there are a few reasons why these type of things are mixed. Like, my overall concern is avoiding a stream fiasco. So, and on the other hand, I don't want to write yet another stream implementation that is a fiasco. So I just don't, to be honest, that's kind of like looking at the complexity that we have. It's, you know, in there, it's a huge problem. So anyway, I just wanted to put this down. I don't know where we are going to land with, but on the client side, I really like the type of API that we have been experimenting with Robert on Undici. It's where when you get a response, you get your header, your status code, your headers, and the body. And I like that API quite a lot. And also, if you want to make a request, you actually pass in a stream, okay? So you don't, you're not, you know, you're passing something in versus you are getting something out that you pipe into, okay? So I don't know, it's it's less complex. It's more like using low-level objects and low-level, instead of having one big object with behavior and state and all the things, using like more, small objects with almost no behavior to move data and split into multiple parts. So I don't know if.
Well, I think we need a balance here, right? Because if that's the API we expose, unless the framework paves over it, the end user just doesn't want.
Yeah, no, but that's.
I say end user, not the ones on this call. I mean, like I'm just a front end engineer who's got to write one.
Oh, I don't care. Like,
API for my
let me be very clear. I don't want an API that a front end engineer can use. I
agree.
It's my take is I want an API that makes the work of framework authors an easier job for framework authors, and provides them all the lower ends so that they can add the cosmetics and the type of API that they want for their user. So I'm talking about as low level and as thin as possible, without, to be honest, with less and less features than what we have right now. Like to go back to the smallest thing that we can do. And the reason is, like, one of the key problems, like this comes from some of the things that I've seen, like the .write-add mess, or the fact that we have so I don't know if you're aware, you have a .write-add and set headers. Bye, Michael. So you have .write-add and set headers. Now set header is and then I think you also have set headers. Now you have 3 ways of setting up an header, and the only way you actually getting anything that is performant is by calling write-add. Every other way is just going to kill your performance badly.
So I think, again, though, I think we need to, this is where I think having a high level design direction is really going to help us, because so I might disagree with you. I'm not sold on my opinion. I'm not strongly opinionated yet, but I think that a disservice we have done in the past in Node Core provided APIs is not going high level enough. This has pushed complexity into the ecosystem in a way that causes a proliferation of NPM packages that all do the exact same thing. And then 3 years later, we end up opening a thing to move make dir p into core. And it's like, well, why wasn't that just in core? Why wasn't that? That's the thing everybody needs. So if everybody needs it, why are we going and pushing that complexity into 10 different web frameworks instead of just having a better high level API provided by core, so that people aren't always forced? And maybe it is that we provide a performant single write header API and not a big, complicated one with 3 different ways. But like, I think we should be really clear on our goals here before we set out, to solve that single technical problem.
This is interesting. Right? So there are 2 things that are more or less orthogonal, which one is the end user API and then there are behaviors. So for example, one of the things that I never understood on why we have done things certain ways is why we are not doing them in Node Core is for example, is compress. Why the heck we are not compressing things, okay? And why are we not, dealing with cookies? That's another one that is, there are some of those that are really. Why are we not serving file from the file system? Sorry to be very, This is we have discussed this. I have almost half written send. I never finished it, unfortunately. It's one of my pet things that I keep coming back to that every now and then. I'm actually rewriting. At some point, I will finish, I'm actually rewriting. Yeah, because it's with an API that it can actually perform faster and perform with HTTP2, which is my current problem, because that current API won't work for HTTP2. So
that current API won't work for a lot of things. The thing is, it's complex. It's complex enough that you haven't finished it, right? These are the kind of things that I totally agree. We should be putting these into core, and we should.
Yeah, I agree. Again, serving file from disk, dealing with a lot of those strategies needs. Those are the things, like, because it's low level and should be transparent for our users, and so on one side. But what we don't need to put this weight on is on the public API. So that is why it's hard, okay? And it's a hard problem, because you don't want to make the external API so super complex to handle with all of those cases. So
I think, though, so a lot of these APIs are not complex per se. I think the implementation is complex because we have too many layers. If we moved a cookie implementation, for example, into a really clean and consistent API in core, I think a lot of things a lot of the problems we have today would go away. Like end user problems, but also framework level problems. Again, shifting the complexity around there, I think is what, anyway, yeah.
Well,
it is a hard
that will not be in core, right? That would be in the mid-tier public API.
Yes, sorry, we need to clarify the language there.
I think that you're right.
Sorry, folks, I need to drop. I'm being called for preparing dinner, cooking dinner.
Yeah, actually, we're over time anyway. Let's set up a deep dive for the high level API, just like we're going to set up a deep dive for the low level API. I'll file an issue right after we end the meeting, and then we can set aside a full hour sometime, hopefully maybe next week, to go in and continue this conversation. So I don't want us to go over.
Perfect.
Okay.
Yep.
All right.
Bye-bye.
See y'all next week.